Hello everyone and welcome to Func Prog Sweden. First up, I would like to welcome all recurring viewers. Thank you for coming back and watching Func Prog Sweden and participating in the community. And then to all new participants, this is Func Prog Sweden, the meetup where we explore functional programming languages and functional programming concepts. With that, let's head over to today's agenda. First, short introduction by me, Magnus. I'll try to keep it short so we can go over to the essentials, the presentations. Then we'll head over to F# from the maintainer's perspective by Petr Semkin. So Peter is part of Microsoft and developing the F# language as it is. It will be very interesting to hear his perspectives on developing the language that a lot of other people uses and see their perspectives and hear what he has to say. And then we go Redefining the Future of Web Development with Haskell by Martin. I'm not going to try to pronounce his last name. So Martin is building web development with Haskell. He's building a DSL interpreter with Haskell. So we'll see what that is and how you can develop your web and future of web development with Haskell. Then, let me see. As always, we'd like to thank our video sponsor, Adabeat. Adabeat is an IT consultancy company with offices in Stockholm and Ho Chi Minh. And the people at Adabeat, including me, are doing mostly functional programming. If you want to know more about Adabeat, head over to the webpage or in social media. Then schedule for the coming autumn. 10th of September, we'll be back with the next live stream. Then 8th of October, we will head over to Kivra here in Stockholm. So if you are in Stockholm, or if you want to come to Stockholm and come to a live event or in-person event, make sure to come to Stockholm on the 8th, and then make sure to also sign up so you get your seat at the Kivra event. Then 5th of November, we're back again with a live stream here on YouTube. And then we haven't decided yet when and where we're going to do things in December. Stay tuned and we'll announce it. If you want to support the community, and yes, you want to support the community, of course, you head over to MeetUp and make sure to join the MeetUp group and make sure to subscribe here on YouTube. And as always, also make sure to join our Discord server. In the Discord server, you can ask more elaborate questions, and we also, as of some meetups now, always have a post-show chat. So if you want to ask more elaborate questions, chat with other people doing functional programming, make sure to join the post-show, or make sure to join the Discord server. If you have questions during the live stream, just shoot them in YouTube or in Discord. With that, let's start. And I'll head over to our first presentation. Welcome, Peter, to Func Prog Sweden.
Hello. Hello, everyone. Yeah. Hi, Func Prog Sweden. Greetings from Prague.
Hello.
You hear me?
We hear you loud and well. Hey, we hear you loud and well.
Yeah. Okay. Yeah. Cool. Greetings from Prague, Czech Republic. It's great to be here with all of you, at least virtually this time. I'm Petr Semkin. I'm a developer on the F# team in .NET. You can find me on GitHub. Hang on, I haven't shared my screen. You can find me on GitHub or X or Stack Overflow and whatever internet by this weird nickname, PS Finaki. Today we'll talk about the job of the programming language compiler maintainer, the highlights and the lowlights of such a role, and probably its less obvious responsibilities. I decided to make this quite a lightweight talk without hardcore coding and stuff, but maybe the next speaker, Martin, will compensate for that. I will talk about half an hour and then leave time for your questions. So, disclaimer, first off, the presentation is called F# from the maintainer's perspective, that assumes the whole team here. And indeed, I compiled the ideas from my colleagues, and still I'm presenting here alone, so the folks cannot cut me short if there is something they disagree with. And for sure, I'm still somewhat biased towards my own opinions. That all means do not take this as an official stance of the team or the company. So with that in place, let's go on. Hang on. Yeah. So, sorry, there is trouble with the screen sharing. See my screen? Oh. Sorry. I guess something happened here. Yeah, right. Sorry. Okay. Yeah. So first of all, who we are? We are Adam, Kevin, Petr, Tomáš, and Vlad. And we are located in Prague, all but Kevin, who is located in the United States somewhere. We are 4 to 6, depending on how you count this. Vlad is the manager, and Petr with the star, he's on leave right now. So yeah, that's depends. You might ask, where is Don? So here's Don. Don is the benevolent dictator for life. And well, these days, he used to be very active in the GitHub repo and commit to the tooling and to the compiler, but now he works in GitHub Next doing some cool AI stuff. And he is mostly a technical advisor for us nowadays. So he chimes in when things are hard. And also he oversees the language suggestions. So he's there with us, but he's like not as active as he used to be there. Now, to our job, here's the list of our responsibilities, so to say. So the following list is not sorted by importance or priority, but rather by my subjective idea of what is least expected to be in this list to what you might have expected. Hence, maintaining F# is last, but certainly not least here. And now I will go through all of those things that I described here. So supporting enterprise F# customers, the reason why this is important is that while Microsoft cannot charge developers for using a programming language, they can charge companies for using products like Visual Studio or Azure, which in turn partially pays our roles. So this makes sense. Hence, if paying customers indirectly through these products have problems with F#, we should respond. Same goes for internal customers, fellow Microsoft colleagues, for whom such things can hinder their business goals. And since F# is not a service, we don't have incidents, we don't have any on-call duty and such, but this is like the closest it can get to that. Such tickets get a priority and require some sort of mitigation, temporarily switching our focus from things like feature development or reviewing PRs from contributors. Internal work. So naturally, I cannot and I won't talk much about this. My point here is to note that not everything we do by far is visible from outside. For example, whatever public system, including our open source repo, is a target for bad actors out there. Hence, there is some work for us in security and compliance space. Also, via Visual Studio, we collect telemetry. There are things like F# editor features, usage, or code fix execution time. And even though this is not personal data, we should still review it, classify it, clean things up, build dashboards, and so on. On top of that, sometimes due to organizational reasons, we get tasks in some F# unrelated areas. Those usually don't take much time. It's more about mental energy, internal communication, and context switch, really. Same goes for hiring. There are hiring seasons in our company when some developers are encouraged and others are, well, very encouraged to engage. This is a great thing to do, but with all the paperwork, this also can take hours and days. All this often explains the fact that sometimes we are less active on GitHub, dedicating less time to PRs from contributors. And we can't comment in every PR, hey, we're not reviewing your contribution right now because we're doing this and this. Some people think that since F# is open source, then everything we do is open source, but that's not entirely the case. Now, let's get to some F# developing here. We do that for sure. That in our case means compiler features. We in the team each of us is pretty much assigned to either a big area like language server protocol or like a big feature like Tomasz was doing nullness support for reference types for very long. That's finally in. We do some performance work, and also we keep our eye on regressions. Regressions take priority because we don't want people to update the version of the language and see their code that used to work not work anymore. That's lame. So we address that. Tooling features include things like code fixes, type hints, analyzers, refactorings, and so on. Infrastructure, that's pretty much everything else. Tests, CI, benchmarks. We have benchmarks in our repo, and documentation is also in our repository. So we do all of that stuff also. Now, promoting F#. That includes conferences and meetups. That's what I'm doing right now. We are pretty much to our own in that regard. It's part of our jobs. So we do present at conferences like .NET Conference. I presented there last year. Also, there is a great community initiative, Amplifying F#. We collaborate in many regards and also sometimes present there at their meetups. There are also internal conferences in Microsoft. Now, we do things like blogs, release notes. .NET has a blog. We post there more or less every month or two these days. Visual Studio release notes, we compile them. Visual Studio also has a blog, and there are like a lot of mediums for that where we can like promote. It's not just like tweeting about stuff. We also do interact with communities. I already noted Amplifying F#, but we have the community on Slack, on Discord, on X, everywhere, Reddit. So we do communicate, people ask questions, we answer. That's also part of our job. Now, F# has the main repo, github.com/net F#. That's where we have the compiler code and the tooling for Visual Studio. But that's not the only thing. There is also a special repository for F# language suggestions. That's where the language itself is kept pretty much, as in people create ideas, what else can we add or how we can further simplify things in the language. And that needs to be approved before getting implemented. So, and that's pretty much the ideological thing, if we want to have this in the language or if we don't want. So that's not the technical implementation. The technical implementation discussions go to the other repository, which is called F# language design. Sorry. That's where the specification is kept. That's where we also create RFCs to update the specification. That's where a lot of technical discussions are happening. So most notably naming, which is of course the hardest thing, how to name this or that API and so on. So we take an eye on that in order to have clear processes and stop some ideas before people invest too much time into them. Now, maintaining the repo. That's what we are called. There are a few things here. First, well, not first maybe, but like one of the important things that we do releases and backports. F# is part of the .NET ecosystem. So there are things beyond and beneath F#. We do things like insertions into Visual Studio because F# editor is component there. So there are processes around that. Sometimes things break also. If there is something important, regressions, we do backports to previous versions of Visual Studio, for example, and that require approvals from committees and some communication. That also might take some time there. CI, of course, needs some service. That's about dependency updates here. Restarting pipelines for PRs, fixing conflicts, this kind of stuff. Planning and roadmaps, we do monthly sprints. We're not very agile because that's a bit about the nature of the open source, I think. We have the repo and sometimes things like regressions pop up and like we should keep some buffer in our planning for them. They might not pop up, but if they do, we should switch our attention, for example. So we take some tasks, we leave some buffer for unexpected things or expected unexpected things. We do issue triage every week. That's for one, to identify regressions that I've talked about, identify by design behavior so that people don't fix something that actually works as it's supposed to. We also do assign priority to those things. And we do PR reviews. Of course, we do PR reviews from the team and from the community. And now I will get to this bigger slide about what we like about our job, what we don't like about our job. I'll stop the good stuff here, which is feeling important, the power. It's a big honor and big responsibility to do something like support for the language, and that since that's a user-facing thing, that feels even more important. Our users are developers, So still, it's pretty much like doing some UI in that regard. In regards to work-life balance, it's possible to have it because we don't have services or on-call, things like that. We don't have very tough deadlines. The whole .NET is rather about doing things right than doing things fast. And it's like whatever we do by the next version of .NET goes there. Other things are postponed. We better test what we committed to and so on. That's nice mentality in a way. Technical challenges, compilers are very hard. A lot of things are happening simultaneously. And well, I'm working 2 years in this team and still my brain breaks all the time. That's a good exercise for the brain. And at the same time, you learn how things work, how the whole infrastructure works. I learned a lot about .NET, about performance in .NET and so on. So it, in a way, makes you think from the compiler perspective. When looking at a different programming language, instead of reading the docs, you think, how would you implement this so that people don't have to read the docs? And then you apply this thinking. So that's an interesting headspace there. Yeah, there are like in our part of Microsoft, there are just like a lot of known people that are like known outside of the company, like Steven Taub, Matt Storgensen, and they are in sibling teams, and that's just like very inspiring to have them there chime in different discussions. That's definitely great inspiration. The management is also very technical. It's easy to discuss some technical things with them. Next point, yeah, C# and is us. I mean, everybody who is in the .NET knows that C# in 10 years is how F# looks like now. They steal. Also, F# is just like more consistent due to some arguably better design decisions in the beginning. And also, last but not least, I just wanted to talk about that a bit more. Support from the community. It keeps my heart warm. You wake up, you log in to work and see somebody created this PR, implementing some feature, language suggestion, or just improving things around, and that's a great start of the work day. That's very very nice. I really love it. Also, we might see people just talking about the language and commenting on that, some activity in amplifying F#. That's all very, very great. The whole community, in my opinion, is very responsive and friendly. The atmosphere is awesome. So that's a big motivator for me. To the other side of that, lack of the power, that's a bit what I talked about before. We do have to do other things about F#, as I already described, and we do need to align with .NET so that we play out in this big .NET puzzle. So that's something for us always to keep in mind. Back to the work-life balance, for a lot of things we do, there is no need to log into the work laptop because of the nature of the open source again. Imagine it's Saturday and you're partying somewhere, not my story at all. And then you get this notification from GitHub that someone faces this issue when compiling their pet project, and you know how to fix it. But it's Saturday and you're partying, but this person is not partying, but instead is doing F# in their spare time and stumbling on this stupid bug where just enabling language preview flag would do the trick. And will you just artificially wait until Monday to say this? Or will you log in to GitHub and break the work-life separation. So it's hard. It can happen everywhere. GitHub, Slack, Discord, Reddit, where you might be involved in some other non-work related activities. It took me really a long time to set up the notifications correctly, if you will, to stay sane in this regard. Another challenge in that space is that it's sometimes we as maintainers have to say no to some contributions, and because after all, once we merge things, we maintain it. We will be with that forever, even if it's implemented by somebody else. Once it's in, it's on us. So we should consider every contribution from that perspective, and some of those things we have to reject. And it just requires a lot of this psychological involvement to not break the relationships in that regard. So saying no to people when they might have done that like of goodwill in their spare time, that's hard. That plays with the nerves a bit. And also another funny thing, or maybe not so funny, I used to use F# in my pet project before I joined that team, and I thought it's a perfect language. It's like, it's all set. It's near English. It's amazing. So that was my mentality before I started looking at things from inside. And suddenly I switched to this world of bugs in F#. You see the issues. People are loud about like things that are not working, and not so loud about things that are working. So you are biased towards just like broken stuff everywhere, and it's just like, how do you even use that? So you need to care about getting this positive wave of feedback. Otherwise, it might seem like doom and gloom, all that stuff. To the technical challenges, compilers are hard, and that's also niche knowledge. There are only so many compilers for programming languages, and there is like not much help on that outside. That's like not React, and for that same reason, AI doesn't help much, because it just doesn't have much materials to learn from, to train the models. So that's something to keep in mind there. Bad side for smart people everywhere is, well, I mean, imposter syndrome, but that happens in IT everywhere. It's more about smart people might assume smart people, which results in some write-only code in the most responsible parts of the system, where, you know, those one-letter variables secretly referring to some academic papers you didn't expect to exist, even all that jazz. C#, even though it envies us, it breaks us. Some people do think about F# there, some people don't. We have to fix interop every now and then. So this year, so far so good, fingers crossed. But like last year was not so bright in that regard. So we just one day wake up and figure out that like some interop scenarios don't work anymore. And that also partially relates to the whole .NET tooling ecosystem. So those breaking scenarios can happen like from different sides. Yeah. And as for support of the community, the thing about the community is that the people there are most likely to do the fun stuff of F#. This means things like implementing feature suggestions or fixing annoying bugs, speeding up some scenarios. And don't get me wrong, this is amazing. And as I said before, one of the biggest motivators for me to work in my team. Also, this is completely understandable, since many of those folks do this for free in their spare time, or for their employers, for their projects. Why would they do the boring stuff? And by boring stuff, I mean things like refactorings, making CI faster, fixing flaky tests, or at least switching off flaky tests. We do get contributions like that, but those are rare. For example, we have the majority of test suites in XUnit, but a couple of them in NUnit. This has happened somehow. To make things worse, a huge bunch of tests also relies on Perl. Yes, on Perl. I mean, this is horrible. Everybody understands that, but it's a big time investment to actually address that. And AI is not capable of this yet. I tried. So when an external contributor implements a language suggestion, this warms up my heart. Yet, if there was anybody in the community who would like migrate the test project from NUnit to XUnit, if this person was in the travelable distance, I would personally come visit their city, take them to the bar, buy them a beer, whatever. That happy I would be in that case. And so, of course, we don't push people for doing these mundane activities. All we need is some understanding that such work is on us. And when people become pushy on why we don't review their PRs, whereas we are fixing fires in the CI, which actually block PRs, that just feels unfair a bit. And also we might become defensive. To finish up, wanted to talk about some trends here. I think we are getting more responsive as a team because, well, first of all, we are more people and there is fresh blood. I think there is better latency in our responses and also more transparency, which is one of the reasons I'm talking about this today. And at the same time, community is more understanding. So the communication is friendly. People sometimes do submit non-technical PRs. And what I really like is that people involved in each other's activities, they review each other's PRs, comment on each other's tickets. That means a lot to us. So because that's taking some of the hardest things, parts of the job and helps us a lot. So, and I hope this talk also strengthens and widens the bridges we're building here. I don't have an entire picture here myself, but from the perspective I have, which are 2 years of work in the role of the F# repo maintainer, our cooperation with the community is remarkable and harmonious, which makes my functional heart beat faster every day. So on that note, I'll finish the talk. Thank you for your attention. If you have any questions, I'm happy to answer.
Thank you very much, Peter. An amazing talk. You already had shout-outs through half of the presentation, like an amazing talk. People love it. Also shout-out for your t-shirt. People have done that in the chat.
Okay.
Yeah, I'll give people a chance to ask questions in the chat, but so I'll start up with my own question. How come you came into F# in the Microsoft F# team?
Yeah, that's part of the story. I was using F# as my pet project, and I thought that's amazing, amazing language. And for a long while there was no open position. There were like fewer people developing the language, and then they opened a few positions in Prague for this new team, and I just jumped in. I thought I actually liked what I was doing before, but I thought that's like once in a lifetime opportunity, and that was, I think, a good decision.
Nice. Also, can you? I'm not aware, so maybe this is open knowledge already, but like the coming release of F#, is that an open, what you're developing or doing, or features?
Yeah, sure. Well, we have something like a public roadmap because we do pretty much everything. We GitHub, there are like projects there what we commit to. but we also are currently in the stage where we pretty much delivered everything we could, because now .NET will be released in November, and now all parts of it get in this phase where just like testing how things work, and fixing bugs, regressions, and so on. So we have just merged the nullness functionality for reference types, which is like a very big deal. So people will get everything of like the future F# using the special compiler flags for language previews. Otherwise, we will definitely summarize what we achieved in the posts closer to the release of the .NET 9, I think.
Cool. Final question. How come F# have more engaged users than C#? Or is that just an impression? Or is or are the F# users more engaged?
Engaged, that's an interesting word. I mean, F#, we are here like in the functional programming meetup. So F# is not pure functional language; it's functional first language in a way. So you get into this we're thinking in terms of like functional programming, and then once you are there, you cannot understand how you lived before, right? So and that's pretty much why people, I guess, stay within the community of the language of their interest in that regard, because there is pretty much no way back. So yeah,
I kind of agree. I see that also. I mean, I think the functional programming community overall, any language, is very engaged, more engaged than the average OOP.
Exactly.
Or OOP. Again, thank you very much, Peter, for your presentation. And I want to do a final shout out also to Amplify F#. The people there, if you're engaged in F#, head over to Amplify F# also.
Amplifying
F#. Yeah, sorry.
.io, yes.
Yeah, exactly. With that, we say thank you very much, Peter. And now we're gonna take on our next presentation. We're gonna say welcome to Martin. Hello, Martin.
Hey, hi, Magnus.
Hey, hello, and welcome to Func Prog Sweden.
Hi, thank you, and thank you everybody for having me. Thank you, Magnus, for inviting me. I do ever so speak about Wasp and what we are doing, but it's more often on the web development side. So I'm kind of excited. I'm kind of pretty excited to talk a bit more on functional side of the things, Haskell and so on. And also thanks Peter for the presentation. It was quite unique. I actually didn't know much about how maintenance was done even though I'm using it, right, Haskell, though I didn't know much about how it was done from the other side. So this was pretty cool. Awesome. Should I just start, right?
Yes, start. Hit it away.
All right. Okay. So the title is maybe a bit vague. Redefining the future of web development with Haskell. You will quickly see what it's about. One fun fact, same as Peter's talk. This one also does talk a bit about developing and maintaining a language. It will be a very different kind of language, though. You will see what kind of language very soon. And even though Peter hoped I would compensate with more code, maybe live coding, that probably won't be happening. I will be having some code though, so maybe that helps a bit. It's just too dangerous to live code, always a risk. So a bit about me. I finished Masters of Computer Science in Zagreb, in Croatia. And I was mostly, dealing with kind of my passion was first maths, then doing competitions. Then I kind of discovered programming, so started competing there more on the algorithmic side, and did internships in kind of exciting places like in Singapore. That was more like academic, bioinformatics, machine learning, doing stuff in C++, R, data science. I also did some internships in Google and Palantir, using I think it was also Google, was also data science, C++, Python. Palantir was though completely different, web development, and that's obviously relevant for this presentation. And then kind of life took me more into the startups direction. So, I was kind of helping startups in Techstars, worked at another startup, LiveBit, and quite a few other kind of adventures in between. And now actually working on Wasp, which is what this talk will be about. So professionally, I kind of mostly work with Java, C and C++, Python, a bit less, but still. And now lately, mostly, web dev, JS, Java, C++, TypeScript, and Haskell. And, quite a bit of other stuff, but, on a smaller scale. So these days, what I'm mostly excited to talk about, and what's mostly in my head is, Wasp. Basically, that's my company, which I'm building with my brother and a couple of other amazing teammates. So it's about web dev and JS in JavaScript and TypeScript, mostly. So that's mostly what I'm kind of excited about. Startups, creating a product, functional programming, especially Haskell, because that's what we are in big part using for Wasp. I do care a lot about clean code. Have always been, like, I think, since the college. And I put this one at the bottom. This is more like a wish list. I always imagine I would love to do some game development, even maybe in Haskell, more like for fun than for actually, building something. And I every summer I spend a couple of days working on that, and then keep it till the next summer. But if you want to talk about that, I will probably be excited also. And now to get more, to start to focus more on Haskell. So how did I get? It was fun for me actually remembering how I got introduced to Haskell, and I realized it happened 14 years ago. If you ask me quickly, I would say it's more like 6 years ago, but time flies by quickly. So it's actually 14 years ago, somewhere at the start of the university. I was actually lucky enough that we had one of, not many universities have it actually. So we had a course on Haskell, which was organized by kind of like an additional activity by one of the professors who was just very passionate about Haskell. And he was also very good at kind of getting that passion, it was very addictive, his passion. I do remember my twin brother. You'll notice I'm doing most of the things with my twin brother. So I'll be mentioning him probably a couple of times. I remember it was summer and he told me, hey, there is this weird language, they say it looks like maths, should be fun. They say it's very hard. Let's do it. The next year, there's like only a couple of days to apply. I remember I didn't want to at the beginning because I said, you're already doing too many things. I already applied for like a allegedly very hard course in Java. So I thought that would be too much, but yeah, he just strong-armed me and it was a great decision. So that's how it started. It was one semester of relatively intensive Haskell course. I think we kind of got so far as monads, so no monostack transformers and stuff like that, but far enough. And since that, I basically started using Haskell whenever I could. Before Haskell, I was mostly using C++ or Java for my university projects, but I remember then I just started using Haskell whenever I could on the university. I think I was like 3 times slower doing it in Haskell, but I had much more fun. And the nice benefit of it was, if it worked, then usually the lab assistant or whoever was checking your code, they would check the code, see Haskell, conclude that's very cool. They don't understand anything, and give you like the full grade if it looks close to working. So that was quite cool. I kind of continued using it and together with my brother on all kind of side projects, and smaller it says here bits and bobs, smaller tasks whenever I could, but nothing kind of big until 4 years ago when brother and I actually started our own company. I think Magnus said that is the I heard him say some points before that it's a nice way to use Haskell is to start your own company. So yeah, and we actually did that, started our own company and have been using Haskell in it for the last 4 years. Actually, the initial course was in big part based on the Learning of Haskell for Great Good. It's a pretty popular book, and I loved it. So I would say my initial learning was mostly coming from there. But I also read. I remember I was also going through the real world Haskell and Haskell programming from first principles. I probably didn't read through all of them, but significant portions. So yeah, if somebody asks me for a recommendation, I usually point them to learn your Haskell for great good, even though it's a bit older, but still I think it's very relevant. And now to actually get to Wasp, which I have been mentioning so much. So what is a Wasp? Wasp is an open source project. It's a framework for building full stack web apps. It's a bit unique though, in the sense that it has its own DSL, so domain specific language. You can see it here, at least a small portion of it. We have our own kind of .wasp file. It's not a Turing complete language. It's a quite simple language, declarative, statically checked. It is typed, although you can't define kind of your own types, but it does have types. And it is actually used to define the high level of your web app. So you kind of define all the high level stuff there, and then you go and implement specific details in popular technologies like, there is here React, Node.js, Prisma, that's like ORM for in the JavaScript ecosystem. Although we are focusing on the JS ecosystem, JavaScript ecosystem. Actually, we are building Wasp in such a way that in the future it will be supporting like polyglot stuff. So you could also do stuff in Python, maybe use other libraries than React, and so on. So that's like a big vision, and a big part of why we are doing it is this kind of unique DSL. Some other important things to mention: Wasp is still in beta, although it's already being used in production in some places. We have a Discord community. We are backed, so we are a startup. It's kind of there is a lot of R&D, to build something like this from scratch. And we are one of the startups backed by Y Combinator initially, and now by also other European and US investors. We're just finishing raising our latest round, which should like sustain us for the next couple of years, which is an awesome thing. All right. And a quick picture of the team. Right now it's 5 of us. This is my twin brother, Matija here, and this is me. We have the same t-shirts, so you know we are twin brothers. And these are Filip, Miha, and Vini. So it's a quite small team, but really, I would say really powerful. And I will also say part of that is also thanks to using Haskell. We are kind of remote team, although most of us are currently in Croatia, but it's not a prerequisite. And quickly, just to give you an idea of how the whole project is going. Lately, it has really been growing pretty well. At the beginning, we had kind of like a slower ramp up. To be honest, a lot of R&D and experimenting on our side. Lately, we kind of figured out like most of the things that are how they should. Let's say I think we nailed some basic concepts and fundamentals. And now kind of stuff is really picking up. Now it's more like let's say a game of just building things as fast as we can. Now we have a pretty good idea of what we are building and what we are doing. Yeah, now we are already around 7,000 GitHub stars across the two repositories, and there's quite a bit of people using Wasp every day, even though it's in beta. So why? It's a bit of a origin story. Why actually create Wasp? You probably saw my when I was talking about my kind of history. I didn't mention web development too much. The funny thing is, like, I was actually more I was always aiming more for a PhD, maybe in the AI or actually bioinformatics. My master's is in bioinformatics on the algorithmic side. So I'm also like speeding up stuff. My brother was also I was like speeding up stuff on the CPU. He was speeding it up on the GPU, stuff like that. CUDA. However, funny thing, somehow we always ended up building some web apps on the side, either for some kind of a side project, or, for example, I was working for a fintech startup at some point, doing cool stuff. We were doing cool calculations for option analytics, but then you need also a web app to show that. Then the bioinformatics startup I worked at, again, we needed a web app. So somehow we always ended up building web apps. And I remember I started first with PHP, then it was jQuery with JavaScript, then Backbone, then Angular, then React with Redux, and without Redux, a lot of different technologies. And the funny part is that brother and I, we always it kind of seemed that web development is harder than computer science, because in computer science, I mean, because of the scope of it, of course, and everything. But there's also a lot of, like, every year or so, or every 2 years, there will be a new tech. So you need to learn this new technology, but you're mostly implementing the same stuff. So you're again implementing some pages and auth and calling stuff from the server, from the client, and maybe some real-time stuff and so on. So a lot of repetition. It's not that I didn't enjoy it, but it kind of felt like, I'm always solving the same problem. And then at some point we kind of, had this idea of, kind of separating specification from implementation. And the core of that idea is the solution we thought of was actually creating this kind of a DSL, so domain-specific language, where you can describe your app on a high level. So that's like detached from any kind of lower level technology. It's more about, it's just, language from that web app people know. It's like I have a page, I have a auth, I have a database, I have this kind of model, stuff like that, right? So you don't want to get into implementation details there. And then you go and implement specific stuff like in React and so on, right? So you have that layer on top that's kind of consistent, and then you can change stuff below kind of faster. By the way, funny thing, Wasp, I know it's like a evil bee, but actually Wasp stands for Web App Specification, right? So that's also kind of coming from this separating specification from the implementation. And kind of things we were always aiming for was, that ideally with that kind of setup, you would write less boilerplate, be more resistant to these shifts in technology, get best practices out of the box and so on. That was the motivation for Wasp. Now, why we use Haskell for Wasp? Multiple reasons. One was we wanted a high-level performance language we can move fast with. We knew we don't need something that's super fast. We knew we don't need that kind of optimization level that you get with C++ or so, right? Performance optimization. But Haskell is pretty fast on its own, right? It's just like if you have some very tight stuff, then of course it makes sense to do it in C++ or Rust or something. But we knew we won't be needing that, so that wasn't an issue. We also knew we don't need any kind of specific memory management. So we wanted something high level, garbage collected, and we wanted something with good support for compiler parser implementation, because we knew we wanted to build our DSL. Haskell was pretty popular for that, right? It still is. And Haskell does have, you could say like a bad side of Haskell is that, sure, ecosystem is not huge, so you might be missing some kind of libraries. Maybe you need something, I don't know, maybe you need a really, really robust SDK for interfacing with Azure or GCP, Google Cloud or something like that. You might not find that easily in Haskell, or it might be a bit outdated, although there is a great one for AWS, Amazonka. But yeah, so it can be an important factor when making a choice, but we kind of knew that, what we're building a CLI tool, a compiler, code generator, so we knew we wanted any kind of special libraries for, cloud computing or maybe data science or stuff like that. So that was also great. And yeah, we knew Haskell very well. I think even though I was mostly using it for side projects and so on, I was playing with it a lot and knew it. I think at that point, I probably knew it as good as I knew Java. Another strong kind of alternative was TypeScript, because we knew we were building a solution for web development, so a lot of people will be actual users will be coming from the TypeScript direction. So you might be wondering why not choose TypeScript. Well, to be honest, one reason was that at that point now also I think I knew Haskell better than TypeScript and liked it somewhat better. And the second reason was that we kind of from some experience we had and what we heard is that anyway, the core part that we will be doing in Haskell will be mostly dealing with compiler stuff. And we didn't kind of expect, it anyway requires pretty specific knowledge, compilers and so on. So anyway, it won't be so easy for casual contributors to contribute. On the other hand, usually people that know Haskell also know a lot about compilers. So it sounded like a pretty good match. Still hard to say, I think both will be fine, but yeah, we really like Haskell. A bit about how Wasp works. So actually at the core of everything is Wasp compiler. Imagine it as a kind of binary CLI in the CLI. So binary written in Haskell. It takes a .wasp file. That is the file written in that DSL I mentioned, which we compile. And it also takes a bunch of, React files, Node.js files, Prisma files, CSS, HTML, right, whatever. So basically all the other stuff that is referenced, by the way, here in .wasp. So it takes all of these, it all goes into Wasp compiler, and it spits out, it's like the code generator actually spits out the whole full stack web app. So produces a client, server, backend, right? Deployment scripts, whatever. It could be even multiple clients, multiple servers. That's something that we'll probably have in the future, like in the web client, mobile client, and so on. So what's kind of quite unique is that it has this kind of compilation step. So you can, it's like opportunity for it to maybe optimize some stuff, inject some stuff in the code, remove something, it gives it a lot of control on what it's actually generating, right? And that is probably the main difference compared to like your typical web framework that you have out there. By the way, fun fact, you could say that any web framework like Ruby on Rails or Next.js or whatever, right, is DSL. However, most of those are like EDSLs in the sense that they're embedded, in the sense that they're quite heavily embedded into the specific language like Ruby, and they don't have, at least not to this degree, this kind of separate compilation step. Maybe to some degrees they do, but not like at this level, and not this heavy code generation, which is really the whole idea of Wasp, maybe even more than the DSL itself. It's kind of more about this whole compilation, very, very, very isolated compilation step and controlled code generation. Maybe a bit more interesting. So let's dive into Wasp compiler. So Wasp compiler is written purely in Haskell. It takes in, as you saw on the previous slide, .wasp file and everything else that's in the kind of source directory, as you said, JS, React, Node, whatever. It has two main parts, analyzer and generator, and the main intermediate representation, which is called app spec, kind of like app specification. So it actually describes your your web application at a high level. It's kind of like in-memory representation of that .wasp file, right, with some additional stuff in it. And it is what decouples the analyzer from the generator. So, so we can in future have multiple frontends, like multiple analyzers, multiple generators, and so on. We are actually right now in the process of implementing an alternative analyzer. I will speak more about that. So alternative frontend, which is enabled by the fact that we have this decoupling. Analyzer is both pretty typical and not. So it's like a typical kind of architecture for a compiler. It has like a parser, which produces a kind of AST type checker, which produces a type checked AST. And then this step, which is a bit more maybe unique, but it evaluates not to like, it doesn't actually execute the language, but it produces this app spec representation. And then that goes into the generator, which generates, like a client, it generates a server, it generates a database, and so on and so on. It uses heavily master templates. There's a very nice library in Haskell for dealing with master templates. And then it produces something. So it actually doesn't write directly to disk, doesn't generate a project directly to disk. It actually creates something called file drafts, which are like in-memory representations of what you want to write. And then there's like a kind of optimized, kind of a smart function, which figures out what actually needs writing, what doesn't, which is what is already written, and so on. And which at the end generates your web app on the disk in like JavaScript and HTML and CSS and so on. I mean, the one, just to be clear about something, this is not, when you're dealing with Wasp, as a Wasp user, Wasp developer who is using Wasp, this is what you care about, right? This, you can go if you want, you can go check out this code, but you're not supposed to be changing this code. This is just the artifacts of compiler, right? Kind of like C++ is compiled to assembly. So what is in the same sense, Wasp compiles to, whatever are the technologies behind it, like JavaScript and all that, so on. Although there is a benefit that if you really need to, you could in theory go take a look, steal something, maybe take all of it and go with it if you're, although there is no need for that, right? Perfect. One important thing to mention here is that even though kind of implemented all this ourselves, I probably know less about compilers than your typical compiler developer, because Wasp is just also pretty simple language. Language is not Turing complete. you're not doing any kind of like for loop optimizations or fusions or whatever, right? So it's in a sense it's relatively simple. It is also although we do use some smart mechanisms here that make this part kind of both fun and complex, some template Haskell and stuff like that. So there are some pretty cool parts here. All right. Besides Wasp compiler, we also have some other interesting parts done in Haskell. So we have Wasp language server. Since it's our language, we have a VS Code extension. We don't have yet extensions for like Vim and Emacs, although Tim is mostly in Emacs and Vim. But we do have Wasp language server, so it's quite easy to implement those extensions. There's, it's like a typical language server. We were lucky kind of that there is an open source version of actually LSP library on Hackage, which is used for actually implementing the Haskell language server. So for the Haskell language itself, right? So that same LSP is open sourced, of course, and we use it to implement the support for Wasp, and it was great. So kind of great experience there. Also, another fun thing we kind of did in Haskell for Wasp. This is more like a side project we did in I think probably a month. So basically, what we did is we implemented let's say GPT wrapper. You give it a title of your web app. You describe your web app in a couple of sentences. Like for example, to the app. It has a main app, lists all the tasks. Each task has description and can be toggled as done or not done. User can add new tasks. Okay, right. So for something pretty simple, it asks you, which GPT combination you want to use, how much do you want. Basically, you're setting the temperature of the LLM, and it generates an app for you in Wasp, right? So it generates a Wasp project for you. This is all done in Haskell. It's not a super complex project, but it's also not trivial. And it was, I have to say, it was a joy implementing it. There was like a small part which basically we're using an OpenAI API, so we kind of modeled communication with that. We make sure that that responses we get are correct. We ask again for them. We check the generated code for correctness. If not, we again request a couple of retries with GPT. So kind of trying to remove that non-deterministic, reduce that non-deterministic behavior of GPT, and so on. And we actually got like it was. I kind of loved it because it really showed. It confirmed again how Haskell you can prototype really quickly, and we actually got really nice results with this. And you can see, this is like a typical example of it kind of figures out. Okay, I'll make a web app for you. It will have these kind of data models and these operations and these pages, and it generates all those. So that was quite fun. All these and some extra stuff, but I won't be mentioning all the small things. We're actually shipping all this as one binary. We found that most convenient and works perfect for now. Helps a lot with the versioning and so on, which is called Wasp. You can actually, so once you install it, you can actually create a new project. You can create it using AI, which uses the AI thing. This one is also used actually by your editor to run the Wasp language server. And you also use it basically for development, right? So it actually runs the generated app for you, like it runs Node in the background, it runs all the React code and so on, database for you. So does telemetry, all a bunch of different stuff, builds it for deployment and so on. So basically, we ship it's one big Cabal project, and it's all shipped as one binary. And to talk about a bit more about the whole Haskell side of things. So we are kind of sticking to the boring Haskell manifesto. And probably you heard about it. I can't remember, was it Chris Dunn or was it Snowman? But some prominent figures in the Haskell community were talking some time ago about the idea of boring Haskell, in the sense of, let's not go, when we are doing a code base, let's not go crazy with the template Haskell and lenses maybe, and some, complex FX systems and so on, right? Like it's good to use them if you need them, but if needed, let's keep them localized. And if you don't, let's not use them. because that really allows, junior developers or maybe intermediate developers and new people joining the team to kind of ramp up, to join quickly, become productive. Code is maybe easier to maintain and so on. So we're also sticking with that. Also, I don't know if I made it clear or not, but the whole team is actually, we are doing part of our coding in Haskell, a lot of our coding also in TypeScript, in JavaScript, in React. So every developer in Wasp is actually dealing with a bunch of different technologies, deployment providers, bunch of stuff, right? So it's kind of, it's not just Haskell that's in our heads. So if we can keep the Haskell code simpler, it does actually help with all the switching, context switching, and working on all this stuff. So we're sticking to that as much as we can. One interesting thing is we started with Stack as a project manager. It was great. I loved how it managed the GHC for us, GHC version, and helped versioning a lot. We did some time ago, we actually switched to Cabal, which mostly like now thanks to GHC app and improvements on Cabal, just proved to be like a simpler option for us, and it works equally well. So now we're on Cabal, and we're also using that for other side projects. So that was one interesting kind of Haskell journey we had. You will see I'll be talking about a couple of these Haskell journeys. Interesting side maybe on the compiler, we started with just parsec, had some kind of ad hoc parser for our language. Then at some point we had this amazing contributor from the USA who joined us for a couple of internships and probably wrote the most complex Haskell code we had, and in a good sense, like really cool stuff. He actually did the whole Alex and Happy thing for us, implemented the proper grammar with all the formal stuff. Used Alex and Happy. That was great. At some point, however, we actually switched to Alex and parsec again. So we replaced Happy with parsec. Happy is awesome, but we were lacking a bit of flexibility on the error handling side, and the error reporting, error recovery, which we needed to be pretty granular, and we needed a lot of control on it because of the language server. So language server has some kind of special needs, and we didn't want to implement like two different things. So we ended up just going with a more custom thing, which was again based on parsec, but also going a level higher than we were going before. So it's kind of like ramped up parsing thing. And I think that's working really well right now. One fun journey we had was this is maybe pretty unique for Wasp. We're actually dealing a lot with file paths. So users bring their own files, right? We are taking those, parsing them, dealing with them, not parsing everything, parsing some stuff. We are then transferring those to the generated project in a lot of them, connecting them with our own stuff that we are generating. So it's a lot of, like this file is here, it's there, I need to import it here. That also means we are often generating like JS import statements in the JS code we are generating. So that also needs to be correct. You want that to work for Linux, for Mac, for Windows. So you need to be also careful about the platform you're working on, the platform that the user is coming from. So a lot of details there about the file paths. And at the beginning, we had quite a few, more than we wanted to, bugs connected to actually the file paths. And if you're in Haskell, always your first thought is, why didn't they capture this in the type system? So I remember I found this amazing library called Pet, written by Chris Dunn. We used that for some time, but then we realized we want even more type safety, so we actually implemented our own thing, which is heavily inspired by Pet, called Strong Pet, and now we are using that, and we love it. I mean, I'm subjective, I wrote it, but I had some people from the team say that they also like it, unless they were just trying to be kind, right? So yeah, I would say awesome experience with that. Surprisingly, usually, Wasp is a pretty big Haskell project at this point. We still don't use lances. We use them just in a couple of small places in LSP, like very localized. We still don't use lances. We probably could, but I think the need just wasn't big enough. I guess we had luck that we didn't have such deeply nested structures or something. So yeah, they'll probably come at some point in the future, but sticking to the boring Haskell manifesto, for now we are kind of avoiding them. we are using like we are not using any super fancy FX systems, just like MTL with some transformers. And some of the, I think, notable, like there are many amazing libraries we are using, but I think some of those that were like a nice surprise, like, oh wow, like this is implemented, was LSP, certainly, that I already mentioned. It was opt-parse applicative, which is like for doing all the CLI stuff, like parsing arguments and producing the help instructions and so on. That's an amazing piece of software. And yeah, we're using Tasty and HSpec for and QuickCheck also for testing, and that's also had a great experience there. Even this stuff like golden tests and end-to-end tests and so on, snapshot testing. A little bit on the StrongPad. So what is that? How does that work? I don't know. Yeah, as I said, I wonder how many projects actually need something like this. I would say all of them. Like now, for me, it's very hard to not use it on any project. But I guess like you probably need some kind of you probably need a bit more of FilePad kind of challenges to actually think of needing something like this. But in Wasp, yeah, it's very needed. As I said, it's inspired and used, and it's inspired by and actually heavily used. So it's like a kind of wrapper around the PET library implemented by Chris Dunn and maintained by his teammates. Just to give you a quick idea of how this works. So imagine, without StrongPad or without even the PET, you would, say, I don't know, I have this kind of variable or function or whatever, get bash profile, which, does some IO and returns a FilePad. In Haskell, if you don't know, FilePad is just a type alias for string, right? So basically, you're not getting much type safety here. It's just any kind of string. With StrongPad, you can be much more elaborate, and you can say, it's FilePad, right? It's system. It could be either system, Windows, or POSIX. Those are like I didn't even know, to be honest, what is all the choices you have before I had to deal with this, but is it like does it have separators on this side in the Windows or on that side POSIX, or it maybe depends on the actually whatever it is. If it needs to adapt to whatever system it's running on, if it's Mac or Linux, it's POSIX. If it's Windows, then you put system. So this path, yeah, it's following the system kind of standard. It's relative to something that's called home directory. So it's a relative path. It's relative to home directory, and it's actually a path that leads to a file, and that file is actually a file called bash profile. By the way, the PET library does also part of this, but if I remember correctly, it doesn't do you can't kind of name these things, which was important for us because it ensured I'm not by accident mixing some paths. So you can't use these names like home dir and bash profile, and StrongPad also pushes a couple of other things step further. I do also remember while implementing StrongPad, I actually realized that PET has some kind of bug in how it differentiates between the standards. So that was also like a nice opportunity. I had a bit of, I managed to meet a bit like some of the maintainers and online GitHub and collaborate a bit with them. So we also merged the fix into PET, which then helped us also to improve the StrongPad. And yeah, simpler but a bit more complete example for you is here. Yeah, for example, you could have a function that says give me a home dir path, similar to this, also IO, but it could be, in this case, yeah, it could be like a absolute file path. You can say to what it's absolute to the root dir, right? And it points to a directory which is called home dir, and you can use like a nameless, is that the correct name? I forgot a bit. This type, which is basically just like a single, has a single value, right? There are a lot of uses to this, and you can check it out like if you want on this Hackage page. And besides that, we're trying to give back when we can to the Haskell community. I feel like we could do a bit, I guess a lot more, but we're also trying as much as we manage next to our other kind of tasks. I would say probably the biggest thing we are doing. So you remember that university course I mentioned at the start about the university course I attended, and that really started this whole journey for me. By the way, a big part of the team also attended that course at some point. So actually, we are now leading that course. A couple of years ago, the professor didn't kind of he was leading the course for quite a big time, but it was I think a lot of work, and he didn't have much time left for it anymore. So we kind of jumped in at the right moment, so it, and took it over, so it continues its life. And now we are leading it for the last couple of years. So that means every semester we have like something between 20 and 30 kind of ambitious university students, computer science students, who we teach Haskell. And I love it. It's funny how in my normal work, I don't use some things like folds and list comprehensions and so on as much as you would expect. It's more, I guess, when you're mostly implementing business logic and you're dealing more with types and so on, business data. So yeah, it's fun. It's actually good kind of refresher for me every year, and it's also just very, very, very rewarding work to teach other people. And the whole team actually, the big part of the team is actively being engaged in this every year. I had the opportunity to actually contribute to creating a new version of Get Started page on Haskell.org. I don't know if you noticed, but I think like a year ago or something like that, me and a couple of other Haskell people from the Haskell community, we got the new page out. To be honest, for me, the most things that drive my ideas how to contribute to Haskell actually come from the university course, because we have this unique opportunity to talk with all the students, and we then see where the new people, how people learning Haskell actually, all the places where they failed, right? So all the places where kind of Haskell actually fails them, be it docs or be it just the ease of usage and so on. And one big part I noticed I felt was important, and I think I noticed is that this kind of first impression when you get to Haskell.org and you want to start was kind of could we use an update? So that was great, and I love the experience of being able to contribute to something kind of that integral in the Haskell community, even though I'm kind of an outsider. I haven't done any big contributions to the Haskell ecosystem before, right? So that was really cool, and I think a big benefit of how Haskell is somewhat smaller community. We also have something called Haskell Handbook on our GitHub. It's not meant like we mostly just write tips and tricks for ourselves there, like in short format, so we don't forget about some stuff. And ideally, it will be also useful to some other people. It's developing pretty slowly, but if you like it, I saw it has quite a couple of GitHub stars, so I'm guessing people do find it useful. I use it usually for myself as a reminder for, like, for example, for template Haskell, right? So I go there, quickly check my kind of cheat sheet for it, and it helps. And also when they can, they try to write some blog post tutorials and so on. I found fun this one. I was trying to solve algorithms for the algorithmic competitions with Haskell, and then comparing Haskell to C++ and so on. And some other members of the team also are writing blog posts. And yeah, this is the last slide. So a bit on the future and learnings. I mean, when you learn another language, I wouldn't say I'm still not sure I would call myself like a Haskell expert. I think I'm somewhere in the there's so much more to learn. But the more you learn, of course, about all the problems and issues. And so Haskell is not perfect, but I have to say I enjoy it a lot. I think it's awesome. I had the opportunity to work with a lot of other languages, and I'm still working with a lot of them, also JavaScript, TypeScript. And I love Haskell. Like if I have the opportunity to, like if Haskell is a good match for some project, I would always kind of go for Haskell at this moment. And silly, I know it like ADT, like how you can define new data types in Haskell. It's such a simple feature, but usually when somebody asks me what is my favorite feature in Haskell, it's just it's so simple to define kind of your problem with that I don't know, I feel like everything, like my brain just loves it, right? Everything goes kind of easy. So I think Rust also has it, but Rust is not high level and garbage collected. So then if you don't want to think about all this stuff, then Haskell is perfect, right? One learning we had with Haskell is that Actually, generalists, like a bit more experienced developers, not too much, like intermediate or a bit more, that have a bit of general knowledge, a couple of languages, they saw multiple things. They learn Haskell really quickly. We have people join the company who have never done anything with Haskell, and they're completely productive in something like 3 months while also doing other stuff, right? Like while already working on Wasp, right? So not like just sitting and learning Haskell, but like learning it a bit by bit, and in 3 months you have them at a really, really good level. So I would say we didn't have problem ramping up people to Haskell, to be honest. Maybe the juniors it will be different, or maybe it wouldn't. I'm not sure. We'll maybe experience that in the future. I did learn that people are scared of Haskell a lot. We saw that the students on our kind of that are taking the course, they all come with a lot of wrong assumptions about it. That it's not, they think it's not Turing complete, or that you can do only specific stuff with it, that you need to know category theory, is super hard, nobody uses it, it doesn't have any ecosystem, stuff like that, right? You can do web development with it, whatever, right? So that's a lot of misconceptions. People are also scared of it, funnily enough. So we are doing, as I said, we are building this solution. So the Wasp, the thing we are building, is not for Haskell developers. It's for web developers, mostly using TypeScript and JavaScript. Funnily enough, if they saw that we are building it with Haskell, even that was enough to scare people away. It's like, oh, this is using Haskell. I need to know Haskell. These people are, not or maybe doing something very, very, very unusual, and that's also something that scares people. So yeah, this kind of reputation, I think this very wrong that Haskell has, can sometimes be a bit tricky. And that, so it's more like I would say something I care about, and I would like to see in the future is just kind of from the Haskell side, is just maybe like promotion and marketing, in the sense that to kind of dispel those wrong assumptions about Haskell. I think that would really help Haskell a lot. And one thing we learned, I think, is that building dev tooling for a language is really hard. So that is it's like building compiler is hard, but then building all the tooling around it, like language server, and integrating it with different editors and so on, that's really hard. It doesn't have anything to do with Haskell specifically. It's just like a hard problem. So yeah, that's maybe like an important lesson. So we'll see. We are also managing that in Wasp in different ways. We might have, as I said, we will be introducing probably like alternative way to defining a DSL, even maybe in TypeScript or something like that, compared to our own DSL, because it will be very easy, much easier to maintain, and so on. You can see, if you want to check that out, you can check more like our Wasp Discord or something for more information. And that's it. Yeah, thank you.
Thank you very much, Martin. A very appreciated talk. Thank you very much.
Cool.
People have shouted out, or I have some questions from the chat for you. Can you compile towards another JavaScript framework than React, or render/compile?
Yes, so that's a very good question. So the whole Wasp is built so you can do it, which is why we have like you can switch, you can implement multiple generators. So you could have generator for React, or generator for Vue or Svelte or whatever. We are focusing right now, to be honest, we are a small team, so we want to get one thing working first. So now it's React Node and Prisma, but yeah, everything is built in such a way that you can also add other front-end languages, different backends, and so on. We will most likely be adding Python first at some point as a backend, because we get some requests for that, and probably something like Vue on the front end.
Of course.
Yeah.
Seems reasonable. If you want to spread the Wasp.
Yes, exactly. Yeah.
Do you keep dynamic part in the user's program is also a question.
Can you repeat that? Do we keep dynamic? Sorry, Magnus.
Yeah. Do you keep dynamic parts in the user's program? Like once it's compiled, do you keep it that? Depends on what you.
Okay. That's I'm not. I think I'll probably be able to answer it in some way. Although I have to admit I'm not entirely sure what it's addressing. But just to clarify it maybe a bit, we are not really doing some heavy compilation. So you have Wasp file, which is just pretty simple declarative static language, and then you just define your kind of your actual implementation in JavaScript files like React Node and so on. So we kind of use that as it is, right? So we don't take out anything, right? So we just use that as it is. And the Wasp part, there's nothing in Wasp code, there's nothing dynamic about it. It's very static. and we just kind of use it to orchestrate the rest of all the other JavaScript code that you provide. So I hope that answers the question.
Yeah, exactly. The question was like, it's part of the compilation. Is some part left for the runtime?
Yeah, actually, no. That's pretty interesting. Yeah, so we just do it all in the compilation time. We spit out the whole project, and then we are actually running that. Yeah, there is no typical runtime. There is no typical runtime in a common sense that you would have in a normal language. Yeah.
How is the UX during development? Do you support hot reload and keep of local states?
Yes, the UX is great. No, of course, I'm joking a bit, but yeah, we're doing our best to make it great. I think also, as Petr mentioned, when you're working on something, you know all the bad parts of it. So if you want to hear all the bad parts about UX, you will learn the most just asking me or any of the teammates. But I think UX is also great in many ways. We do have hot reloading and stuff like that. Yeah, normally, of course. So that's all. That is all there. If probably some small things are missing, like so for example, we don't have stuff like I think lazy routes, or all this coming very soon. We don't have a static server side. We don't have server side rendering yet, but all that is kind of coming. Wasp is still in beta, so our focus is mostly now on getting these kind of innovative parts working the best we can, and then the some of the, let's say, more expected parts we are adding now and soon. Yeah. Great.
Final question: is there a link to the course you're having? People are asking in the chat.
A link to the that's interesting. Actually, so in the presentation I gave, which I haven't shared with anybody. All right, so I can actually share the link later, probably. I would be happy to. I would be happy to share it in Discord. The course is not streamed or anything, and is heavily following the book that I mentioned, Learn Your Haskell for Greater Good. So a big part of experience you can get there. The big part of experience you can't get is that we actually do, like, we work with students, we do code reviews, we have homeworks, and then like small exams, right? So all that is, and we also have live classes where we help them. We did have discussion last year if we should be live streaming the whole thing. So let's talk about it. If there is enough interest, I think I can also take that to the rest of the guys, and maybe convince them to live stream the whole team, or at least record it so we can put it somewhere. So that would be,
exactly. Yeah. Again, thank you very much, Martin.
Thank you, Magnus.
Yeah, you're welcome. You're welcome. And thank you very much, everyone, for joining tonight. And thank you very much for everyone asking and being very engaged in the chat. It's always nice to see people engaged, and also nice for the people doing presentations that you're engaged in the chat. And it's also nice for us organizing the meetup. Now, we'll end for tonight. And for those of you who want to tonight or today, depends on where you are, please head over to the Discord server and ask questions and join in and ask more questions, more elaborate questions. And also Martin will share the link to the course and etc. So thanks, and maybe I see and hear some of you in Discord. Bye for tonight.